In the last three videos about understanding Next.js and Vercel, I was trying to cover all the infrastructure components that come into play for a Next.js based app to function properly in Vercel infrastructure. And we talked about a lot of things. We talked about serverless technologies, AWS Lambdas, Cloudflare workers. We also talked about CDNs. In the AWS ecosystem, we have CloudFront. In the Cloudflare ecosystem, we have the Cloudflare Edge CDN. Then we also talked about serverless databases and why we use them in a Next.js based environment, especially when a Next.js based app is deployed in Vercel, which is a serverless based setup. And all these foundation knowledge is pretty much all there is to it to understand how Next.js works in Vercel. In this video, there is nothing additional that we can add to it, especially when we are talking about the infrastructure tech stack. We will just talk about how all these different technologies that we've been discussing in the past three videos come into play for a Next.js based app to work in Vercel the way it works. That means how serverless, how CDNs, how edge compute, all these things come together. And the reason I took a while to release this video is because I was waiting for the Vercel ship 2025 to make sure that they don't release anything major, at least when it comes to the infrastructure components, and this video gets outdated so soon. But turns out there was nothing architecturally different in this year's Vercel ship. The major announcements were the cost reduction in fluid compute. We've talked about fluid compute in the serverless video. It's Vercel's own proprietary infrastructure setup where they try to run multiple instances of a function, a serverless functions concurrently to save cost, unlike other serverless based technology like AWS Lambda, which charge you for the whole lifetime of your function. In Vercel's fluid compute, they charge you based on all the time slices when your function was actually running. It was actually consuming CPU cycles, right? So this year they basically made more announcements in that technology, and you have more cost reduction. And they also removed things like build queue, etc., right? Nothing that affects all the things that we've been talking so far. So with that, let's jump into the final video and we'll wrap this short series about understanding Next.js and Vercel. It is mostly about understanding serverless technology, but since Next.js is such a famous framework and most of the open source repositories, most of the open source companies these days use Next.js for this serverless setup, and front-end engineers coming from React-based background and getting onboarded into a Next.js code base, making sense of all these things, because Next.js and Vercel together is such an infrastructure heavy setup, is a little tricky. That's why I thought of making this series, since I also struggled a lot understanding how these things come together. And after a lot of research through the Next.js docs, to the Vercel docs, to the Vercel blogs and subreddits and Hacker News articles, etc., through a lot of resources, I somehow managed to put together a mind map. I'm pretty sure I'm wrong in a lot of ways, and I miss a lot of other infrastructure components that also play a crucial role. But this should be good enough for you to ship Next.js based products, Next.js based backends, and to understand serverless technologies enough to not mess up your infrastructure setup, right? Not to incur crazy cloud costs, etc., etc. Now, before we get into the Next.js part, I want to talk a little about the history of two things. One is MPA and the second is SPA. Basically, a multi-page application and single-page application. When the web movement or when the web technology started around, let's say, 1989 to 1990 by Tim Berners-Lee, and the web project started and companies started to have their own websites, etc., right? And the thing to focus here is the web started as a means to serve documents all around the world through HTML, right? the vision of web was it is a collection of hyperlinks, and a document can have multiple hyperlinks, and one link will have the location of the another web page, and when you click on it, that web page will be fetched and the browser will show you that document. So that was initially the vision as a means to share information through internet. And starting from that, after a while, a lot of companies started to have static websites, and they started to share information through HTML and web hosting services, etc., etc. And that's also when technologies like CDNs came into place, because since most of the documents were static, there is no component of dynamism there, you could use CDNs to serve your content, serve your static content all around the world in minimal time. And starting from there, the concept of dynamic content came into place, and it started mostly with CGI scripts. So if you search for CGI scripts, so it's called Common Gateway Interface, and there were some kind of scripting technologies for enabling the static sites, the static HTML sites, to have some amount of logic attached to them. So if you fetch an HTML document, that HTML document will trigger the execution of this script, and you can add some components of some dynamic components into that. So that was the initial movement of dynamic component with CGI. And starting from there, we reached the era of PHP. Now, PHP took the CGI setup to the next level. So in a PHP based setup, you can have your scripts and your HTML that is embedded in those scripts. And you can also have database queries and database setups, etc. in that same application. And when you request for a page, you can run some amount of database logic, some amount of server-side logic. And depending on the result of that logic, you can change the content of the page, right? Instead of serving static sites to all your users, you can customize your sites as per different users. You can show their username and their email and the content that is specially catered to them, right? And that was the first major adoption of dynamic sites. The concept of MPA, the reason we call it a multi-page application is because the way it usually worked was it worked seamlessly with our HTTP request response lifecycle. So in your browser, you, let's say, type something like https example.com/about. Now, when you go to this link in your browser, what happens? Your browser as a client makes a request to your server, whatever hosting provider, whatever web hosting provider that is serving your site from this domain. It makes a request, a client request to that server. And this route, the /about, is usually attached to something like a file which is called about.php. And this file has all the corresponding logic to run the database queries and run any server-side logic and return an HTML page back to the browser, and the browser will immediately parse and render that HTML page, and you can see the content. And the thing to focus here is every route in your browser is directly attached to some file, some logic in your server side. So every time you navigated to a different page, let's say you want to go to profile page, now that will make another request to your server, and it will have another file called profile.php that will run some server-side logic, and then it will return an HTML page. Each route in your browser corresponded to a particular logic in your server side. That's why we called it as multi-page application. Each navigation made an HTTP request to fetch some amount of HTML and some amount of JavaScript attached to that HTML and rendered it in your browser. And that was the case for a long time until we reached at something called SPAs. SPAs are known as single page applications, and the way they work, for example, if you've worked with technology like Angular or React or Vue, Svelte, all these modern frameworks, They are all majorly focused on SPS or single page application. And this is the way they work. When you land on a particular domain, let's say you land here, example.com/about. Does not matter where you land. The first time you visit from your browser's URL bar, the first time you make a request to the domain, if it is a single page application, it fetches a single HTML file, and that is usually called something like index.html. And a single HTML file is able to serve your whole application. And the way it works is, the first time you land on this particular domain in your browser, it makes an HTTP request and this HTML file is fetched. And this is the first thing that your browser fetches. And this particular HTML file will have all the JavaScript or the CSS, whatever fonts or images, whatever that is needed for this particular route. Because we have concepts like lazy loading, which basically means depending on what route you are fetching, the server, the whatever hosting provider that is serving your single page application, it will send chunks, and that is only relevant to that route, right? So when you land on this particular route and is a single page application, the first thing it will fetch is the index.html and all the JavaScript it needs to render this page, and CSS, images, fonts, etc., etc. After that point, when you make any kind of navigation, let's say you go to the next route, which is /profile route. Now, at this point, it does not fetch any additional HTML file. The HTML file it fetched the first time you landed on the website, and assuming that you have not hard reloaded your site yet, the HTML file is still there. The way it works is, the moment you navigate to another route, we have client-side routers. For example, if you are working in React ecosystem, we have routers like React Router. What they do, they track the state of your URL through browser APIs. And whenever that changes, they lazily, since most of the client-side applications, SPS, implement some kind of lazy loading functionality to save bandwidth and to offer optimization, etc., etc. They fetch the JavaScript and all the assets that is needed for that particular route, and they load it in the client side in the browser. And your browser does not perform a hard navigation. We say hard navigation when every time you navigate from one route to another, your browser performs a full reload. Right? It makes a new HTTP request and it fetches the HTML page for that route. That is called a hard navigation. And this shallow navigation happens in a single page application. Whenever you changed out, assuming you have already loaded the first route, any route, whenever you navigate from that point on, we only fetch the JavaScript and the assets that we need, and we load that page in the browser, in the client side, without making any additional HTTP requests for a new HTML file. And one major difference here is the way data fetching worked between MPS and SPS. In MPS, whenever the server got a new request, it executed all the database queries or whatever server-side logic, and it generated a new HTML page and it sent it to the browser. And the browser just rendered that HTML page without processing any logic or any data fetching on the client side. That is the way MPS worked, which means that server-side data fetching. But with SPS, because of this technology called AJAX, asynchronous JavaScript, the client, after loading the page, after loading the HTML, JavaScript, etc., the whatever JavaScript logic is there on the client side, that JavaScript logic can fetch data from the server side using APIs. And after fetching the data, it can replace those parts of the site that needs to be updated as per the server-side data. Because of this technology called AJAX and the ability for the browsers to make API calls to our servers and to fetch JSON data and to render that using any kind of front-end framework, React, Svelte, Vue, etc. So that is one major difference between MPS and SPS. In MPS, we made all the data fetching logic in the server side and sent the HTML directly to the client. And in SPS, we just fetch all the HTML, CSS, JavaScript, whatever we need to load the logic, to load the UI, etc. And we made the data fetching on the client side through API calls. And we just replace those parts that are dynamic. And that's pretty much all about MPS and SPS. And the reason we are talking about this is because Next.js is primarily a server-side framework. So it is kind of a hybrid between MPS and SPS. And it is important to know the difference between MPS and SPS to get the intuition better of how Next.js actually works, how the Next.js router works, etc., etc. So with that, we can safely jump into the Next.js discussion, how all the components of Next.js works, especially when it comes to the infrastructure side, the serverless side, etc., etc. We're not going to talk or discuss about various Next.js concepts like React server-side components, the caching layer, etc., etc. Right? There are like 100 different things in Next.js, and we, especially in this series, want to focus on the infrastructure side. What happens on the server side in a typical Next.js based app when you're deploying on the Vercel infrastructure. And to understand the next part, I'm assuming you have some familiarity and you have worked with Next.js before and deployed on Vercel, etc. Otherwise, it won't really make any sense. Since we have started with the Next.js discussion, Next.js has 3 major rendering strategies. So I think that's the best way to start the discussion since they affect the infrastructure setup a lot. So primarily Next.js has 3 major rendering strategies. One we can say SSG is the static site generation, and then we have SSG with ISR is incremental static regeneration, and then we have SSR. So without going too much into the syntax of how Next.js works and how you can create these 3 things, we'll leave that part. That is a completely different discussion, and that is like a tutorial for Next.js. We just want to understand how they work. So if you have structured your app in a way that you are making use of SSG, which is static site generation, which basically means that when you run the command next build, when we actually run this command next build, this is the command which takes all your application code and it compiles it, parses it, does all different kinds of bundling and different kinds of things, and it generates a particular output which is ready to be deployed on different servers depending on what infrastructure setup you are using. Now when you run this next build command, if you have some parts in your application you are making use of, let's say, get static site props, etc., all your pages that are supposed to be statically generated, what that means is all the React code, all the React CSS code that you have written in the JSX format, all of that will be compiled and an HTML file will be generated, which will have the markup, the CSS, the linked JavaScript files, etc., etc., which will be a completely static file, and which file will be enough to be rendered in a browser, given the browser can fetch that file, right? So that we call a completely static file, which means that the server does not need to perform any other additional database queries or any other server-side logic. It can just send the file and rest of the things the browser can manage. So that we call as a static file. So what we mean by static site generation is all the files which are supposed to be statically generated, given you have followed all the Next.js docs to generate static sites at the given part. What will happen during the build time, the HTML files will be rendered and all those files will be saved somewhere. Now we'll come to this part where they will be saved, but assuming you are running in your local, you have run next build, then all those files will be stored in something called .next folder, right? And when you do next start, which is starting a production server using Next.js, all those files will be statically served instead of being rendered on the server or executing any server-side logic. That's what we mean by static site generation. Now, what do we mean by static site generation with incremental static regeneration? Now, ISR is a revolutionary concept that Vercel came up with in its initial days. which takes care of a lot of pain points when it comes to SSG, is the static site generation. So assuming you have a blog site, right? You run a blogging SaaS, let's say something like, since blogs are mostly static content, so a rendering strategy like static site generation during build time makes a lot of sense for a blogging sites, which basically means that you fetch the content of all the blogs from your database, and that happens during the build time because you have adopted the static site generation rendering strategy. So you fetch all these blog posts and you render them, which basically means that all those React JSX code with CSS, all that will be converted into an HTML file with linked JavaScript and CSS. All those blog posts will be rendered to HTML and they will be saved somewhere. And when a new request comes for a particular blog, just take that file and serve it, which is a very fast process because you don't really perform any other database query or any other server-side logic, which works great for a blogging site. The whole setup works great. But if you are a major blogging provider, something like Medium or Hashnode, then it becomes a problem, because in SSG, what you're doing in your build time, you're fetching all the blog posts. The blog posts can be in thousands, and if it's a old platform like Medium, it can be in millions and billions, in fact. In that case, you're fetching all these blogs from your database every time your application is built, and then you are rendering them, which is also a slow process. You are rendering them all to HTML and you're saving them, and that's when your deployment is successful, which can be a painstakingly long time if you are a big platform, if you are already a SaaS, big SaaS. That is the reason incremental static regeneration is a game-changing strategy that Vercel introduced to take care of some of the problems, and this problem, the long build times, is one of them. So what happens is, in incremental static regeneration, first, for the problem of long build times, what you can do, Next.js provides primitives to set up your SSG flow in a way that you can skip all the rendering and all the static site generation flow during the build time. And you can go with the other option where what happens, all your static content is not built during the build time, but when the first request, let's say you have a new blog post and it is not statically generated during the build time. So what happens, the first time a request comes, a new request comes for, let's say, blog number 520, 546. And this is not statically generated during the build time. So using incremental static regeneration, what happens, the server renders this particular blog page by fetching it from the database, and then it saves it into the ISR cache. So ISR cache is a different location where all the pages that were statically generated during the build time is stored as a cache. Now that blog post is server rendered during the runtime when a actual request hits that particular blog, and it is saved into the cache. Now from that point on, whenever a new request comes, instead of server rendering or executing any server-side logic, that particular blog post can be directly served from the ISR cache. And because of this, you can completely skip the long build times of SSG static site generation using ISR. Now, the second thing of ISR is the revalidation strategy. If you're going with static site generation and you have a requirement that you want to invalidate all the cache of your static content, let's say you want to invalidate all the static content of your site after, let's say, 1 week. For that, you can set a particular timer in your SSG flow, and when that timer exceeds, all your static content, the cached content, will be invalidated, and all the new content can be fetched from your database or from your CMS, whatever your actual data sources. It will be cached again for the next 1 week, right? So those are the two major advantages of using ISR. And now moving on to SSR. SSR is pretty intuitive when it comes to the other rendering strategies. SSR basically means that every time you make a new request, so let's say if we have a client and a server, so the way SSR works is every time a new request for a particular route comes, let's say we are talking about blogs. So every time a new request for this particular blog, the blog 546 comes, instead of serving from a cache, a already rendered HTML page, what happens? The server renders that HTML page by processing the JSX, making the database query, and sends that HTML page. And this happens every time a new request comes, which basically means that that page is completely dynamic. We don't cache anything. Everything, all the logic to render that particular page is executed every time a new request comes. So SSR is pretty infra heavy because a lot of bandwidth and a lot of server-side logic is run every time you get a new request. But it also has its place for completely dynamic content. Let's say you are working with pages like dashboard pages or stock tickers, etc., where everything is completely dynamic. Then we don't opt for any kind of caching like SSGs or client-side fetching, any kind of caching. We go for server-side rendering because we want the fresh data. We want all the server-side logic to be executed every time. That's just some Next.js basics that I wanted to talk about to start the discussion. But we have not yet discussed the infrastructure parts, which is the key discussion point for this video. So I'll keep this short since we have already talked about all these different technologies that we are going to talk about now in this video. I won't go too deep into the technologies itself, but I'll just mention how Next.js and Vercel makes use of them. A typical deployment, especially when you are working with Vercel, works when you do a git push. Vercel tracks a particular branch. You can define what branch you want to set for deployments, for prod deployments or whatever's different environment, staging environment, etc. So Vercel tracks that particular branch, and every time you push a new commit through GitHub or whatever your version tracking software is, every time you push a new commit, Vercel starts a new deployment. Now, what does it mean to start a new deployment? It starts basically with next build, which goes to all your code bases, does all this bundling and code splitting and lazy loading, etc. Like there are 100 different things that go into a actual build step. But after the build is successful, assuming that you are deploying to Vercel, a new directory is created called .vercel. And inside this, we have all the generated files, all the generated content that is going to be used for your deployment, for your infrastructure deployment. So that build step actually performs a couple of steps to generate all these files, which are going to be deployed in multiple places. Now, we'll talk about what are all those files one by one. Now, majorly, we have routes, which are basically pages in a Next.js based app. So starting with routes or pages, because we can also have API routes, right? Now a route or a page can be either it can be an SSR page, or it can be statically generated also, depending on how you are configuring that page, right? We already talked about the difference between SSR and SSG. So it can be either of these two, or it can be a client side. Now the difference is depending on what kind of rendering strategy you are opting for in that page or in that route, the deployment for that will be different. For example, for an SSR based route, that also can be of two types. If a page or a route is server side rendered, then it can also have two kind of categories. One is you are not using the edge runtime. In Next.js, you can export a variable, something like export const runtime equals to edge. If you do something like this, then it means that you want to execute whatever server-side logic in an edge runtime. And we have already talked about what is the difference between an edge runtime and a Node.js runtime. Edge runtime is basically a browser compatible runtime, which does not have access to all the APIs that we do have access to in a typical Node.js based environment. Things like the file system or some of the crypto APIs or the database drivers, etc., etc. So if a particular router page is SSR, then we also have two options. If you have exported a variable called runtime equals to edge, then the runtime for this will be edge. Otherwise, by default, the runtime is Node.js. Depending on the runtime, this can be deployed in two different ways. If it is a Node.js runtime, now all the things that we are going to talk about and that we are talking about is happening in a serverless environment. Vercel completely uses a serverless infrastructure. There is no component or no part of this whole setup where a typical server like an EC2 instance or a Kubernetes pod is used. All of the things, does not matter what infrastructure is being used behind the scenes, but all of these things are happening in a serverless environment. That is the thing you have to keep in mind, right? So assuming that if it is a Node.js based runtime, which is the default runtime, if you don't export a runtime edge from your file, if it is a Node.js based runtime, then that file is going to be deployed as a serverless Lambda in a single region. Usually the default region is, as per the Vercel docs, it is Washington. So as per Vercel's ideology, they try to deploy all your computing instance in a single region, usually which is Washington, so that you don't make a lot of round trips to your database, because most of the data sources, most of the companies, they deploy their data sources in this region, in the AWS region, which is closer to Washington. They have chosen this particular region as their default computing instance deployment region. So if your SSR route is a Node.js runtime, then that particular file is going to be extracted, and Vercel is going to deploy that file, that logic, whatever logic that is inside that file, as a completely different Lambda, which is an AWS Lambda, in this particular region, is the Washington region. But if it is an edge runtime, you have chosen for an edge runtime by exporting this particular runtime variable from your file. In that case, your route, your page is going to be deployed as a Cloudflare worker. Now we have already talked about Cloudflare workers in the serverless video. What is the difference between AWS Lambda and Cloudflare workers? So AWS Lambda, assuming you are not going for Lambda Edge, provides a complete Node.js environment, which means that you don't have any kind of limitations like you do with edge runtimes. But a Cloudflare worker usually provides an edge runtime, which means that it has zero cold start time, but it comes with its limitations that you cannot execute all the APIs which you have access to in a particular typical Node.js based environment, right? So that is the difference, especially when you are going with server-side rendering for a particular route or a particular page. Then depending on the runtime you choose, the Vercel can either deploy it to an AWS Lambda or it can deploy it to a Cloudflare worker. Similarly, let's say you are going a particular page, you are opting for a particular page, you are opting for static site generation. So at this step, if a page is configured for a static site generation workflow, then for that, what happens during build time, we generate HTML files and JS files and CSS files, whatever is generated after rendering a particular component or a particular page. Now, all those files, since it is a completely static route, all those files are uploaded to a durable storage, like something like S3, an S3 bucket. And whenever you make a request for that particular route, that static content is served from that S3 bucket back to you without any additional server-side logic. That's why static site rendering is very fast. Just make one request, you get the files, and the browser does the rest of the work. Now that's all about routes and pages. Now let's talk about routes, especially API routes, and API routes also called as route handlers. In this also we have a similar kind of setup depending on the existence of this variable, this particular variable, which says that you want to opt for the edge runtime. Depending on the existence of this variable, A particular route handler can either be a Bliss Lambda function or it can be a Cloudflare worker. So all your route handlers, depending on if the runtime is Edge or the runtime is Node.js. If you have configured the runtime is Node.js, then that particular route will be deployed as a function in an AWS Lambda. But if the runtime is Edge, then that particular API, that particular function will be deployed as a Cloudflare worker. Now there is one more detail to be noted here is all these different routes, all these different pages, and the fact that I mentioned all of them are deployed either as an AWS Lambda function or a Cloudflare worker function, basically serverless functions. So Vercel has a limit depending on what plan you are going for, but it has a limit, I think around you can only have 12 different functions in a Vercel app. So how does it work? Even though we have, let's say, hundreds of pages, hundreds of API routes in our app, since the limit is only 12 functions, either Lambda functions or Cloudflare worker functions, any kind of serverless functions, the way Vercel solves this is it groups depending on the configuration. If you have different timeout configuration, different revalidation logic, depending on the configuration, it bundles different functions into a single function. Let's say you have two different SSR pages. You have about, if you have profile and you also have, let's say, dashboard. These are two SSR pages and both of them are, let's say, Node.js based runtimes. So they will be deployed as AWS Lambda functions. So if they both have similar kind of setup, what Vercel will do, it will group both of these API routes, both of these functions in a single Lambda function, right? All the logic to render both these pages will be inside a single Lambda. That's how it solves the limitation of maximum 12 serverless functions for a particular app. Now, moving on, we have talked about routes for pages and routes for API routes, and that takes care of our AWS Lambda, Cloudflare worker. And if it is any kind of SSG based setup, we are deploying it to S3. Now in a Next.js app, we also have a concept called middleware. Now middleware is a piece of logic. You can have one middleware.ts or middleware.js, TS or JS file in your Next.js app. And the purpose of this file, this logic is every time a new client request comes, the first point of contact is this middleware logic, because this middleware initially it was deployed as an edge compute basically in Cloudflare workers. So your middleware logic will be deployed as a Cloudflare worker in different regions, right? So it is very fast to reach that piece of logic like redirection or request blocking, etc., all these key pieces of logic, lightweight logic, but key pieces of logic inside your middleware, which will be deployed as Cloudflare workers across the world. But now they have also, Next.js team also have started supporting Node.js runtimes for middleware logic, which will have different kinds of setups. But in a typical middleware setup, as it was initially announced, what happened, whatever logic that is written inside middleware.ts or middleware.js is taken and it is deployed as a completely separate Cloudflare worker, which is kind of the first point of contact before the request reaches your app. So you can do different kinds of logic. So that is the third category. Next is static content and public folder. So if you have worked in Next.js app, we usually store some lightweight pieces of static content like images, fonts, or all our bundled JavaScript and CSS files. All this static content that gets generated during the build step, all this static content is taken and it is uploaded to S3 for a durable storage, an object storage, and it is also cached in CDN. So Vercel has a very large network of CDN, which is an edge network, and it's not documented anywhere whether they are using AWS CloudFront or Cloudflare CDN, but it can be either of those, or they might also have proprietary infrastructure, their own CDN infrastructure. That's not documented anywhere, but that's not the important thing. All the static content is uploaded to S3, and they are also cached in CDNs, so that whenever you make a request for this static content, you get response very fast because of the CDN caching thing. We have already talked about how the whole CDN workflow works in the video that is completely dedicated to CDNs, so you can watch that. So we'll not go too deep into CDN in this video. Next comes the image optimization. So now it's also not documented whether this particular piece of logic, the logic for image optimization, is deployed in a completely different server or where it is deployed, etc., etc. But in Next.js, you have a feature of opting into image optimization, which basically makes use of this library called Sharp for optimizing your images, changing the quality, the weights, the sizes, depending on the client request, depending on the client device, the network, etc., etc. And that piece of logic for processing all this request and generating an image and sending that to client, that can also be deployed as a separate server, an image optimization server that can be a Lambda server or also a Cloudflare worker. So with that, I think we have pretty much covered all the different kinds of files that get generated during the build step, and all of them are taken, and depending on what kind of file that is and what kind of configuration of that file is, that is deployed in a completely different infrastructure setup. One thing that comes to mind is how the routing works in all this different infrastructure, how all of these things come together. So Vercel also has a service called the gateway service. So after your Next.js app is built, the routing logic is taken and it is converted into something called as a routing table or any other internal data structure that they might be generating. And that routing table is basically used to configure some kind of setup which resembles what we can say as API gateway. So in the serverless video, we discussed that all the logic that we write in a serverless environments are deployed as different functions, which are triggered whenever a new request reaches that particular function. But the problem is if it is deployed in a completely different function, which only gets triggered by some kind of event, how do we actually trigger that? Using domains, using IPs, using routes. So that's where the concept of API gateway comes from. API gateway is basically kind of a routing layer on top of serverless technologies, which takes care of mapping your routes, say API, let's say about or profile or whatever routes that your app might have. The purpose of API gateway is it takes all these routes and sends that particular request to different services depending on the configuration of your app. For example, during the build time, we discussed that your app might generate multiple pages and they can be deployed either in a Cloudflare worker or AWS Lambda, or for static content, they will be uploaded to S3 and cached in CDN, etc., right? All of the components are deployed in different places. So when you actually make a request, so the first thing that gets triggered is the API gateway. And the purpose of that is depending on what kind of request that is and what kind of route that you're trying to fetch, it forwards that particular request to either a CDN, to S3, to a particular AWS Lambda or a particular Cloudflare worker, etc., etc. So this is the component. This is the final infrastructure component, an API gateway. So most likely it can be an AWS API gateway, but again, that is not documented anywhere. So you can assume it can be a setup which is similar to AWS API gateway, which brings all these different infrastructure components together. We have covered pretty much a very basic and a high level understanding of what happens when you deploy a particular Next.js app in a Vercel based infrastructure. Now, there is another initiative which is called Open Next.js. This is basically an open source effort by the community, by the Next.js community, by the TypeScript community, to provide enough resources, to provide enough packages and enough configuration so that you can take a particular Next.js based app and you can deploy it in your own infrastructure, but you will have access to all the features which you would have if you had deployed to a Vercel based setup. So in the comparison page, you can see that these are all the features that are supported if you deploy in an OpenNext based setup as compared to a Vercel based setup. So there are different ways to deploy a Next.js based app. You can also deploy it as a Docker container, or you can deploy it directly in any VPS without containerizing it. And you can also deploy it the way Vercel deploys. And to do that, you need a lot of configurations and you need a lot of infrastructure based logic so that you don't break any of the flows. And that's the reason OpenNext is an initiative by the community which tries to provide all the features out of the box through configuration which resembles to a Vercel based setup. So it can have features like function splitting, serverless, and warmer function, which is not something Vercel offers, but it is an optimization offered by OpenNext itself. An external middleware, which in case of OpenNext, it is deployed as an AWS Lambda Edge function. But in case of Vercel, it is deployed as a Cloudflare worker. Same for edge runtime and ISR and on-demand revalidation, etc., etc. Like all these features, they have different components, and different features are deployed using different infrastructure components. So if you want to self-host a Next.js based app, then OpenNext is your best strategy. So if you want to self-host your Next.js based app and you don't want to use Vercel, even though going for Vercel makes the most sense in the long run, but assuming that you have a organization and you already make use of AWS infrastructure heavily and you want to keep your front-end deployments or your app deployments limited to your own infrastructure, your own AWS infrastructure, in that case, you can go for self-hosting, and OpenNext makes a lot of sense since there are no major surprises in the way Next.js is supposed to work as compared to Vercel versus OpenNext. Right? They try to support all of the features. Similarly, they also have a section for Cloudflare. If you want to deploy your Next.js based app in a Cloudflare infrastructure, you can do that, and same for Netlify. All these are different packages, different configurations are maintained by the community and regularly updated. So if you're someone who is interested in self-hosting your Next.js app, you can definitely look into OpenNext. With that, I think we are done with this discussion of how Next.js and Vercel works, how serverless technologies work, and how Vercel uses all these serverless technologies, CDNs, AWS Lambda, Cloudflare workers, S3, API gateway, all these different technologies together to make your Next.js app function in the most optimized way.